Hi and Assalamu alaikum. Welcome back once again to Technology Information Channel. Today in this video I am going to explain the schematic of Caterpillar C-13 model and C-15 and C-18 model generator set with the EMCP 4.4 electrical system. Complete detail in this video. Before starting the video, I have small request to all new and fresh comer. If you are first time on my channel, please make sure to subscribe and also don't forget to hit the bell notification to getting latest update videos. So let's begin. As you can see here, first of all, we are little overview about the basic concept of the most common electrical system, which is used the perfect concept. As you can see here, here is the harness and wire electrical schematic system. So let me little bit overview on it. As you can see here, these two switches, and switch normally open and switch normally close. Okay, switch normally open means that's, as you can see, this is normally open. Before, without supply, this was normally closed. When supply is applied, this normally closed is converted to normally open. Same like vice versa scenario here. This normally open and this normally closed switch. As you can see, before that was normally open. When supply is applied, let's convert to the normally close. As you can see here, normally close. And how the ground connection has look like, as you can see here, ground wire and ground case, as you can see here, and reed switch. Okay, and also the sensor level, and as you can see, relay magnetic. Okay, and also solenoid, and also the magnetic large solenoid. Okay, this is the main concept of the all electrical system, but that's mostly used in a generator and EMCP controller, most likely used in this model generator. So let me move to the basic electrical wiring diagram of the EMCP 4.4 with the control panel and with the bus bar. Okay, so first of all, as you can see here, that's one. This is our EMCP 4.4. This is the EMCP 4.4 connector. Okay, EMCP 4.4 behind the connectors, as you can see, all the connection and the wiring pin out and pin in. Okay, as you can see here, as you can see, ECCR and then FCR and then spare 1 and then spare 2 and then spare 3 and then spare 4 and then GRR and then CAR. Okay, from the EMCP 4.4, as you can see here, the ECCR is used for the cranking. Okay, from the pins 116 is going to this relay coil, ECCR relay, and then pin 94 is going to the FCR, fuel control relay. Okay, the wire number, as you can see here, also mentioned with the 5954 A214 white 18 number gauge. Okay, also R956 A29 A229 white 18 number gauge. Okay, as you can see here, this is going to the crank and that's going to the fuel control relay, and that's all may remain as a spare, you can use for any your purpose. Okay, and here, as you can see here, GRR means the generator running. Pin 68 is going to the this relay coil, the generator is running. Okay, that will indicate the generator is running. Okay, and as you can see here, CAR, this is used for the common alarm. Okay, pin 67, this is going to the common alarm relay. Okay, as you can see here, this is the diagram of the relay. As you can see, this is the diagram of the relay. This is the relay coil, and the another side is all one. As you can see, the one wire, if we follow this one wire, as you can see, this one wire is all common for the all relay. As you can see, common for the all relay. Okay, and this is the relay coil. As you can see here, 1 and 5 is a input supply of the relay coil from the pin 67 for the alarm, pin 68 for the GRR, so like that. So this is the relay of the EMCP 4.4, cranking, fuel and others. So let's move to the another wiring diagram little bit. Check it out. Starting circuit. As you can see, this is our starting circuit. As you can see, this is our starter motor. As you can see, the red wire, this is the live battery wire. As you can see here, the battery, this generator using most twin batteries in a series that's run on 24-volt DC system. As you can see, the 24-volt live wire is coming to the starter motor battery point, and then this one is coming from the, as you can see, the customer terminal. This goes to distribute to the EMCP. As you can see, customer terminal TB1. As you can see, this is going the wire 11 and 820 A2 89 white wire number gauge 10. As you can see here, MCB 4, MCB 5, MCB 6, MCB 7. Okay, these all are going to the, as you can see, and then distribute to the other system. Okay, so MCB 4, MCB 5, MCB 6, MCB 7, 16 ampere, 16 ampere, 10 ampere and 20 ampere. Okay, that's going to the, this here is spliced and then going to the input terminal 16 and input terminal 15. Okay, and then going to the this way. As you can see, the lock G11, lock D13 and lock G14. Okay, this is another terminal TB numbers, but you know the concept of the wiring. So let's move to the another section. As you can see here, service connector. As you can see, A, B, D, E, G, F, C. This is the, and the white color codes also mentioned with the that. As you can see, here is our fuel level sender. Fuel level sender. As you can see, from the connector, the connector C2 connector is connect with the C4. Okay, this two wire number 2 is coming from the this wire number gauge number 16, and it's coming from the, as you can see, the customer terminal 7. Customer terminal 7. As you can see, this 2, 7 and 8. Okay, and also this is coming from the, as you can see, the analog input, analog input negative and negative. Okay, spare analog input and output. As you can see, this one, and this 2 wire is going to the this connector. This is the disconnector is connect with this connector, and then this 2 wire, as you can see, going to this fuel level sender. As you can see here, P74 734 is coming to the fuel level sender A, and then B is connected with the pin 35, and also the C is, as you can see, pin number 18 is going to the, that's look like a shield wire. Okay, and also LCL switch and mix pickup. Okay, MAC pickup means the magnetic pickup, NCL, and also the LCL. As you can see, the LCL is coming from the, as you can see, if you follow the discrete input pin number 15, 115, programmable discrete input 1. Okay, and then going to this connector pin number 11, and then out wire number Y9 A3 C-29 white 18 number and going to the LCL. Okay, low coolant level switch, and then as you can see here, mag pickup, that's main magnetic pickup unit, and VSN, little bit zoom it, SIG. Okay, so as you can see here, this is our EMCP connection, which is only used, okay, not all are used in EMCP have 70 pin connectors. As you can see here, J1 P1 to 5 full analog power, okay, and then analog return and programmable analog tree, and pin 67 is a battery, okay, and pin 46 is ground switch, and pin 56 is ground switch, and pin 18 is a digital return, okay. And then this used for the AutoCAD data link connectors, this 5 you no need. And also the main connection is our, as you can see, pin 65, 63 and 61. The pin 65 and the pin 52, this is the supply of the EMCP 4.4 controller to turning on the controller, okay. And it's also the pin 48 and the pin 53 and pin 70, okay. This is used for the key switch, as you can see the pin 70, that's one, and that's sent to the, this is a splice junction, and then as you can see coming from the connector pin 10, and then as you can see, if you follow that, as you can see here, as you can see here, APR, as you can see here, APR, and then going to the this way log G12, okay. And the downside is, you can see here, this wire is coming to the ECM switch, okay, ECM switch. If you follow the lock G12, the lock G12, as you can see here, from the ECM 70 pin connector, 120 pin connector, the ECU have 120 pin connector, as you can see 53 and 33. This is the output for the, as you can see, yes, wire 103 8 to 15 white 18 number gauge, and that's going to the EPR and ECM switch, okay. EPR means engine ECM power relay, okay. Let's control the ECM turning on and off switch, okay. So let's move to the ECCR, the engine cranking relay, and as you can see the log G12, as you can see the log G12 also going to the engine cranking relay, and this is our starter motor, as you can see here, starter motor log H13, and then when this, as you can see, this connector, this, if you follow that wire, this is coming to the EMC, another connector which is I explained already, is C2 and AC4 to the pin 27, and then going to the starter motor, okay. This is the starter motor to the S terminal, okay, to the S terminal for the starting, okay. The another side is grounded, and here is a direct battery feeding, and the starter motor stator is connected with the this starter motor solenoid, and also it's grounded with the engine chassis, okay. Here we have, as you can see here, we have 3 grounded, okay. It's 3 grounded already connected with the alternator and with the charging alternator and with the starter motor, and the engine chassis. As you can see here, charging alternator. One live wire is coming from the battery. As you can see, this red wire here is already spliced, this wire. If you follow this wire, this is coming to this connector, the connector C5 and KC1. This two connector is connect male and female, and this wire coming out from the 3 and then enter in a charging alternator D plus, B plus, sorry, as you can see, B plus. Okay, and the charging alternator body is already grounded, and one wire is connected with the this connector KC1 and 2 and then out, and that's why here is a splice junction of the ground, and this ground is distributed to also connect to an EMCP 4.4. Okay, so that's already explained. As you can see here we have as you can see here we have discrete input. This is the spare input. You can use it for the everything. You program it and you can use it for everything. This is the spare output. As you can see here, spare digital output. Okay, and as you can see here, the parallel star series delta, then series star. This is the connection with the alternator. So let me little focus on it. As you can see here, parallel star, how the VR is connected. So let me check it out. As you can see here, we have the control pinner. The control pinner have two breaker, three-pole breaker. As you can see here is a neutral TB, and here's a neutral TB and three phases. As you can see, the three phases L1 UA1, L2 VA1, L3 WA1. This three phases directly going to connect with the main alternator stator. Okay, as you can see here, we have three current transformer. That's one, and that's one. Okay, as you can see here, we have exciter. The exciter two wire, this two wire. If we follow that two wire, this two wire is coming to the wire number is E1 ENGG A17 white 18 number, and also ENG GA20 white 18 number gauge. This two wire is coming to this connector ENGGSC1 and ENC2, and this two wire is coming to the input pin 35 and pin 37. This is the in this connector. Okay, and then pin 35 and pin 37 is out. The wire number is here is change F5 and F6, A93 and A94 white 18 number gauge. As you can see here is EM10 controller module 1980 91 87. This four wire, if you follow this coming to this connector 16 28 29 32, and here's two wire is missing, two is out. Okay, and if you follow this two wire, this one and this one, it's going to the alternator, and here is this two, one is connected between T11 and T10, and one is connected directly with the neutral T12, the center point. Okay, and so M10 10 ampere 15 ampere module, and from this connector EMCP 4.4, from the 70 pin 28, pin 8, pin 19. There's three wire. As you can see, pulse width modulation, pulse width modulation, pulse width modulation, positive, negative, and shield. This three wire is coming to this connector. The connector number is C7 366 93 70 2 1 and 3. That's not you can connect. As you can see, first is 2 and then 1 and then 3. Okay, understand? So the video is going too long. If you have further to read and understand this diagram, this video link in the description, I will provide my Gmail. If you have need this wiring diagram, I will send you. Thanks for watching. See you all next time. Allah Hafiz.